Hey, this is Christopher.
And Luik.
And we are going to show you how to build an FPV race wing.
But not just any wing, a spec wing.
And a spec wing is a very specific kind of wing that meets very specific tolerances so that we're not flying wings that are disproportionate to one another, but every wing should fly the same. That way pilots are matched against pilots. Now this wing is really, really cool. It is a design by
Chris Klick
of RiteWing. We're also going to feature the brand new Spec motor from T-Motor. We've been really impressed with it so far. It is newly released. We've gotten our hands on 2 of these motors that they graciously sent to us to test out, and we're going to do a full review on these as well. Alright, so inside of the Spec wing kit, we get a whole bunch of really cool stuff. Let's go through it. We have the wing beds, which come in handy when we want to glue and spar things. You can also do it from the inside. Woo! This is, as you can see, the version 3. So this is brand new.
What are these lines for?
That's a great question. So those lines are where we are going to lay our spars. That's right. One thing I love about every RiteWing is that they are CNC cut. All of the spar grooves are already in. The battery bays, the equipment bay is already scored for you. It is a finely tuned precision flying machine, and I am really knocked out by Chris's engineering. You will not find a more beautifully cut wing on the market. We also get
Elevons.
These are balsa wood, pretty beefy actually. A lot of companies send the thinner ones, but these ones are pretty thick. Then we also get this beautiful sealed package of all the other goodies in the box, which include our winglets. The Spec wing has no barrier fences or vertical stabilizers, that should be noted. It also has the battery bay floor, the equipment bay floor, and then the covers, as well as, you know what this is?
The motor mount.
Very good. As well as the hardware to keep that secure. Then they also include a landing skid for the nose, which I don't use, but a lot of people like them. So we want to spar up the aircraft next. And to do so, we actually want to utilize the wing beds that were included in the kit. These come in real handy, especially when you're trying to keep everything true and straight, which is critical in building a competitive spec wing. And we're going to join these 2 surfaces. This is actually going to be our very first application of Starbond EM2000 and the accelerator. We're going to open up the box. It comes with 2 nozzles, which is really great. A lot of companies only send you one, the one that comes on the bottle. We're going to cut just a little bit out of this. It also has a really great little saver cap with a pin needle in the center so we don't get any clogs as it's stored. And it comes with a whole bunch of these tiny little applicator needles, which make applying the glue to really tight spots even more easy. Louie, I'm gonna have you apply just a little bit of glue right along that seam. Good. Now normally this would take a few minutes to dry, maybe less, but we have accelerator. I want you to spray right down the center. Doesn't need much. Boom. Good. Count to 10. There is our first Starbond joint. Woo! That just demonstrates how fast the accelerator cures the Starbond. I mean, that's not coming off. That's pretty awesome. All right, there are lots of ways that you can join the 2 halves or 3 sections of any wing together. Today, we're gonna do a little bit of a mixture. We're gonna apply some clear Gorilla Glue.
Gorilla Glue.
I love Gorilla Glue because it does not expand like the traditional white Gorilla Glue, and it is extremely strong. We're gonna keep that toward the center of each piece. Then around the outside of every surface junction, we're gonna use the Starbond. That way, we have a really tight seal immediately drying so we can keep moving on with the project. Meanwhile, the Gorilla Clear Glue is going to be working behind the scenes to keep everything joined together. Even clear Gorilla Glue still needs a little bit of water to activate it. Now I'm going to take a little bit of the Starbond and I'm going to go around your cuts. Alright, so we've kind of made this kind of interesting design with two different glues. So we're going to make sure we have both halves lined up properly, the top side with the top side, press them together, hit right there. Ready? Go. That's good. Now let's do the center section. We're going to roll it over. I want you to hit the nose for me, hit that center section, and tail. Beautiful. Now you can do this traditional methods using something more like Goop, using contact adhesive only, and take more time doing it. But for today, we're trying to accelerate this process a little bit. And we'll note that if we did it right, it should line up in the bed perfectly and no fluctuation. This is solid in the bed. So good job. Okay, this is the fun part. Sparring! Sparring! We're gonna do the top side first and then the bottom side. We're gonna take an X-Acto blade and just gently go through and make sure that every channel that has been pre-CNC cut is clear of obstructions. We're just gently tracing any slot that you see.
I'm going to do these ones too.
That's the servo slot. That whole block is gonna pop out. Push it out. Let's spar with them, shall we? On guard! We take the spar and we're gonna lay it into every slot. You usually push the tip in a little bit to where it stops. One really important thing is you don't want to run your finger down these fiberglass spars. You will get little bits of fiberglass in your finger and it will hurt for a long time. Gently press them in.
Satisfying when they're done.
Yeah, it is, isn't it? What I typically like to do is find where the end mark is, raise it up out of the bed a touch, and then move the cutters in. Snip it. So I have maybe 1/8 of an inch play between the end of the spar and the wing edge. We're going to continue sparring the rest of the top side of the Spec wing. Again, notice we are not putting any glue on this yet. We are just laying all the spars in, ready to receive glue in a second. One thing to note, see how we have some cross sections? We have spars that actually overlay each other. You have to decide which spars you want to go on top and which spars you want to go on the bottom. Now that we have the spars laid out, we get to hit it with the EM2000 and then the accelerator to lock this wing exactly as we have it laid out.
Like on the Kraken in the Lego movie.
Sweet! Exactly right, man. That's exactly what it is. We are freezing these Lego pieces in place forever. Now you can't do this with traditional methods of sparring the wing because you have the spar and you're laying it in with Goop or welders or whatever it is you're using. It just gets messy. Then you got to put all these weights on it, pin things together, and it takes a lot of time. This is literally going to be done in less than 15 minutes. That's crazy. I'm going to take the Starbond and I'm going to lay a bead in right over top. Now what you're going to notice as I go along is that the EPP is actually going to wick in some of the Starbond. A lot of people are wondering, hey, why don't you put the Starbond in first and then lay the spar on top? Well, first of all, my fingers would get stuck all over the place. We don't like that. And secondly, you don't need to because the Starbond actually gets wicked into the EPP foam and you're going to see that happen right before your very eyes. So now I'm making sure this spar is exactly the way I want it. I'm going to take the Starbond and I'm going to start laying a bead in. Now you can watch it. It's actually going to get sucked in to the EPP. I'm going to take a paper towel and just gently smooth out some of these lines. Now comes the fun part. We're going to hit every line. Go ahead. It's been less than 20 seconds, and aside from the accelerant, which is still kind of evaporating, the glue is completely solid and dry to the touch. You have never seen a wing sparred so quickly or so strongly ever. Ever?
Ever.
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 Wow. What do you think?
We've done beautiful work.
We have done beautiful work. Now we're gonna flip it over, do the other side. Knives up.
Mom's away! Let's go!
This is Sparta! One other design decision that we have to make is whether or not we want the spar to be above or below the battery bay floor on this model. I actually like to trim off this corner piece. One nice thing this prevents is this corner from popping up from this edge and creating an issue with airflow over the bottom of the wing. It also keeps that point from protruding through our laminate or tape. You got this! You got this! Starbond up. Hit the accelerator. Starbond EM2000, thick. It's amazing. High performance, premium cyanoacrylate. It's awesome stuff. We love it. So dude, that's the wing. I mean, that is amazing. Nice! Ooh. What we're gonna do next is sand this down until it has a nice feathery finish. Now what we're gonna do is lay the wing back in its bed and use 120 grit sandpaper on this DeWalt radial hand sander. And we're gonna try to get this down to a nice, consistent, feathery finish. So we're about halfway through the sanding process. Remember that what you're looking for is a really nice feathery finish. It should be soft to the touch. Whereas if you're hitting something that feels more like plastic, we want to get rid of that. Let's keep going. Now that the wing is sanded, the last step we have to do to secure the spars is to do a very, very thin layer of goop. What this does is helps lock the spars into what's called the wing matrix. So the whole composition of the wing now is going to be bound together with the spars, the EPP, the Starbond, the goop, and that will help adhere to the tape or laminate that you're gonna put on top. The reason we do the goop after we sand is because you do not want to sand goop. It's just a hot mess, gets boogers everywhere, it's really gross. So we're gonna lay down a bead of goop along the spar and then take our finger in a bag and smooth it down. We're going to install the equipment bay floor, battery bay floor, servo bay floors. We will use the approximate depth of the bay floor and cut out that much material for the floor to recess inside. When you're done, you can just pull up what you've cut away. It means that the floor now is going to sit right in there.
I'm gonna put the battery bay floor into the battery bay slot.
Awesome. See, that fits perfect. So then you're going to do the same thing with the battery bay floor. We're going to trim off these two corners, the servos, and then the top hatch, but we won't fix the top hatch yet. We are not going to use the kicker on ABS plastic because unlike chloroplast, ABS will actually start to be corroded by the chemical that's in the accelerator. So we're going to leave that off and just let this dry natural.
Why is your other glue thing in the fridge?
That's a great question. Best way to store Starbond in a cool, dry place. It preserves the lifetime of the glue and the accelerator. So always want to keep them cool. While we're here on the bottom side, we're going to do the servo doors as well. They're going to just kind of squish. So they're flat. Try to keep it as flat as possible without bending. I'm going to take a little Starbond. I'm going to go around the inside leg. Now we're going to cut in the recess for the equipment bay hatch. It's the top cover, and it's going to go on just like the battery bay and the equipment bay. However, later on, when we actually permanently affix it, we will cut a thin slice into the bottom portion to create a flap. All right, Luik, what are we going to do next?
Install the motor mount.
And what motor are we going to be using?
The T motor. Oh.
This is the new Spec wing motor from T-Motor. It is sanctioned by the FPVWRA, the FPV Wing Racing Association. And it is great for us to have a brand new motor to use on our builds. Big shout out to T-Motor for sending us this one to put on the RiteWing. It's gonna be awesome. All right, so this motor mount is going to slide into the rear bay. Looks like Chris put 2 cut marks right here. We're gonna use those cut marks and actually make this a little bit shorter. Because if we go too far, it's gonna actually protrude into the equipment bay. So we wanna trim it off right there. And the T-Motor is gonna fit right in there, just like that.
So perfect.
Boy, that is a great fit. And if we've done it right, it should slide right in, just like that. So I actually like to put the motor mounts in after we have laminated or taped the wing. That way we are allowing the tape to form the wing, and then this will be even tighter when we push it in. Now that the wing is sparred, it is sanded, all the bay floors are in, the electrical compartment hatch is cut and fit. Now we are going to tape our wing. This is a really important note because whatever material you choose will determine how you handle the wing. Now we are going to use a special contact adhesive. It is called 3M90. So we have 3 main reasons why we like Scotch HD heavy duty packing tape.
Number 1.
The first reason is that tape has a higher tensile strength than laminate, so it's stronger.
Number 2.
Scotch HD shipping tape does not stretch, whereas laminate does. This means that it is much more solid in the instance of a crash, and trust me, we have crashed a lot. And where laminate has destroyed wings, tape has held them together.
And number 3.
The third reason is that you get to lay each piece down individually, crisscrossing them as you move forward from the trailing edge to the leading edge. This actually adds a lot more integrity and strength to the wing than just a single piece of laminate. Ready to do this?
Yeah.
Let's go. I'm going to use the 3M90 and I'm going to spray a nice coating along this part of the leading edge and the bottom part of the leading edge. And we're going to take it inside, and within the next 3 minutes, we're going to put on that first piece of reinforced Scotch packing tape. Here we go. Just about the length of the wing. Beautiful. Lay this down. And you don't need a lot of tension, but I'm going to run my finger down the center. I'm going to fold back top, and then fold back the bottom. This reinforced packing tape is very, very strong. In the event of an impact, it will keep the leading edge from really being destroyed. We're only giving this about 2 minutes of dry time, maybe 3 tops. Trying to get it while it's pretty much still wet. And then what I like to do is just take the back end, the rounded part of the knife, and just run it down making sure that everything is nice and tight and flush. Now we're going to move on to the trailing edge of the wing, which has a little bit of compound in it, some angles that we have to account for, but that's not too difficult. Let's go. We're going to spray from here around this bend and all the way out to the wingtip, as well as right here on this surface and a little bit on the bottom. I have a feeling I'm going to lose a finger before this video is done. We're just going piece by piece, keeping really good control over every decision we make. The last place we're going to apply this reinforced tape to is actually the end of the wing. Why? Because I've found recently that affixing the winglet to the foam itself causes damage when the plane crashes, because those winglets pull away a lot of foam. Instead, adhering them to tape means that when the winglet pops off, as they always do, it doesn't take any foam with it, it just pulls some tape, if anything. Most of the time, it's just pulling off the glue. So that's awesome. Let's do it. Go inside. Now that we have the leading edge, the trailing edge, and the two winglets done, what are we going to do next?
Put tape all over the rest of the wing.
We're going to spray the top part and lay the tape down. When we're done there, we will
spray the bottom part
and
tape it.
You got it. Oh! All right, we're gonna take the 3M90 and spray the entire top part of the wing, and then we're gonna go lay down strips of tape. By the way, we've also put a little bit of tape here on the battery bay floor and the electronics bay floor, just to keep the 3M90 from sticking to it. We'll pull that tape off later. All right, let's do it. All right, this technique has been perfected by all the guys out at NorCal FPV. Big shout out to you guys. Appreciate the insights that you have in preserving what has been kind of a traditionally old method, and I feel like it's a better method. But that's, again, just personal preference. If you like lamb with an iron, you do it, man. So again, the way this goes down, and you can watch my other videos on this, is I'm gonna line it up right on the back of the trailing edge. Just gonna very gently allow my finger to move down the center of the tape. I'm not pulling very hard at all. If you do that, you're gonna start to warp the wing. When I get to the front leading edge right here, I take my knife. There we go. Once that's down, I just take my knife and gently smooth that out. Again, none of my finished cuts will be with the serrated edge of the tape dispenser. I'll always use a straight edge. Press this down. This next piece moving forward is going to overlay the previous piece by about a quarter of an inch. Letting this overlap about a quarter of an inch. That way the airflow never meets a raised tape line. This is extremely strong, and the weight increase is negligible. All right, then we get up to the nose section. We stop crisscrossing, and we just go flush. Top side. What we will do real quick too is we're going to wrap some of this tape down, cut through diagonally out from these corners, perpendicular off this angle here, right along here. You're just picking my lines as I go. And all of these pieces we're going to fold down. You're looking good. Top side done. Doing the same thing that we did to the top. Now that it's all done, the last thing we have to do is a final piece of tape along the left leading edge and the right leading edge. That way the airflow now is always moving over a sealed seam. And we'll cut out these slots, start to put electronics in, Elevons, servos, control horns. Man, she's coming along. First, I measured and trimmed the Elevon to the size and shape that I wanted it, then taped it, affixed it to the wing with tape. Then I mounted the servo, ran the servo line into the equipment bay, hot glued the servo in place, and then also affixed the control horn, which I'm going to finish up with some CA glue. Then I'm going to open up the hole a little bit on the servo extension arm as well as the control horn on the Elevon. From there, we'll affix the clevises and the 256 control rod arm. I'm taking great care to make sure that the leading edge of this piece of tape is actually hidden up underneath the Elevon fold. Alright, servos, control rods, clevises, and control horns all in place. Next, I'm going to revisit the cut we made for the motor mount by opening the tape back up and test fitting the motor mount one more time. Just enough to lock this plate in. That is going to be beautiful. Coming off the XT60 connector, I have a couple things going on. First is this Acon 30 amp ESC, which is going to go to the bullet connectors and then over to our brand new T-motor. Next, I have a dedicated BEC, which is sending 5 volts over to our receiver, in this case an FR Sky D4R2. And lastly, I have a small little JST connector, which is going to power our video transmitter. Now, I have been using these FXT video transmitters. They're pretty good, but I'm being introduced to some better stuff. I have a brand new Team Black Sheep video transmitter coming to me via Ross Smith out of Florida. Then we'll be using a Runcam Swift 2 for our FPV camera, which I'm going to cut directly into the foam. Its cables will run down into the battery bay, across the floor covered by some black electrical tape, and then into the equipment bay. Alright, now we're going to focus on the T-motor. So the packaging in this T-motor is really nice. I love the box, I love the decals, the back information is pretty handy, and it comes with this little bag of hardware. We're going to tear this open. Inside we get the prop adapter, a washer, as well as all the little screws that come with it. And we've affixed the prop adapter. We also have to solder on our own bullet connectors. Didn't come with them, that's not terrible. It would have been really convenient and nice, but in this case, we're gonna have to do it ourselves. Then we're gonna weigh it to see how heavy it is and try it out on the electrical system. Start by hitting the on button. Put the motor on. What do we got?
62.
62 grams. All right. last step.
Winglets.
Winglets.
Right,
Yep.
left,
Yep.
up,
Yep.
down.
Power on the throttle. Now give me some. Woo! Is that all the way? All right, I thought of one more thing that this wing needs. Decals.
Oh, yes.
And I thought we would put Astro Panda FPV on it. You know why?
Why?
This is your wing.
What? Seriously? Thank you.
You're welcome, buddy. What do you think?
It's awesome.
I'm very proud of you.
Thank you.
You're an amazing son.
Thank you.
So you have some other fans out there. And so we thank Chris Klick at RiteWing for the wing. We thank T-Motor for the motors. We thank APC Props for the props. And a big shout out to Starbond for helping us build this wing. We're gonna have a lot of great years ahead, flying and building together.
Thank you.
Thank you, guys. You're welcome. This is a world-class, real FPV race wing. Spec wing by RiteWing. That's awesome.
A little bit nose heavy.
Nice, buddy! How you feel?
It's awesome!
I'm proud of you.
Thank you to all the sponsors. This thing is awesome.